Hello everyone, welcome back to another remote sensing lecture video. And in this lecture video I want to talk about the third criteria for training data, and that is the idea of spectral homogeneity. Spectral homogeneity. And so this one's a little bit harder to explain with an actual image. It's far easier to explain using these spectral plots here. And the idea here behind spectral homogeneity is that we want to make sure that the variation, I should clarify here, that the spectral variation within classes is less than the spectral variation between classes. Right, and this is actually going to be similar to what we talked about in unsupervised classification in terms of looking at the plot on the left here. Right, this is the exact same concept. Right, we have reflectance in band 1, reflectance in band 2, and each one of these dots represents a training point. And so on the left, right, you can see that we have these clearly distinct patterns. Right? We have a pattern here. Oop. Right, we have a pattern here, a pattern here, and a pattern here. Right, each class is very clearly distinct from each other. Right, that's what spectral homogeneity means. If we look over here at the bad example, right, you'll see that we kind of have a distinct class here. But what do we do about the red, about the green, and the orange? Right, you can see that they're kind of intermixed together. Right, this is bad spectral homogeneity. Right, this means that more than likely, no matter what model you use, you're going to have a really hard time differentiating between whatever your orange is, say it's urban, and whatever your green is, say it's vegetation. Right? Your model is going to really struggle with these two classes. So this is bad, right? You do not want to see this. So what does this mean? Well, it means one of two things. Well, it really means one of three things. It either means, one, the image that you're using, you just simply can't differentiate between those classes, so these should really become one class. Again, that goes back to the idea of rethinking what surface features you're going to map. Two, it means you were really sloppy in your training data generation, and you picked pixels that were maybe mixed. Maybe they were on the edge between the two classes. Or three, it just means that your spatial resolution is such that your objects are just always mixed pixels, right? We talked about mixed pixels in a previous video, so hopefully you remember that term, right? The idea that a pixel is being contributed to by more than one land surface feature. And so if you see this sort of really bad mixing of the two classes, you're going to have to do something about that, right? Because this is completely useless, right? This sort of variation here is completely useless. You want to make sure that your variation looks like something like this. Okay? So again, spectral homogeneity means that we're trying to make sure that when we plot our training data, that it always looks like this, that we have these clearly distinct groups versus like this, where everything's sort of mixed together. This has high variation and is bad. This has low variation and is good. Hopefully that makes sense. Again, if you have any questions, I encourage you to go back, rewatch the part you're confused about, and as always, please reach out. Thank you.